Okay, so this lesson is going to be the second one in our Module 11. We're going to be comparing data displayed in dot plots. This is the second in 3 where we analyze and compare data, and in most cases we're learning to do this visually with graphs. So today is going to be comparing two sets of data displayed in the dot plots. And the question we're going to be answering is, how do you compare those two sets of data? And there are ways to do it in 3 different categories in most cases. First of all, looking at the shapes of the plots will tell you a lot about the two different plots or populations. What do the centers of each one of them tell you, and what does the spread tell you between the two? So you can also compare medians and the range of dot plots numerically. So ultimately we'll use the shape to guide us, but then the numbers to quantify in the end. So from our last lesson, we remember that dot plots are graphs that organize small amounts of data using dots or something similar. You can get creative to show the frequency or the number of times that each value occurs. So this is an example from the last lesson, number of people in a household. And from a dot graph you can find the center using either the median, which is the middle point, or the mean, which is the average. You can describe the shape, and there will be different shapes, and you can also observe the range from the min to the max to see if that tells you something about the two different plots. So that's what you can learn from a dot plot. In this lesson we're going to compare two dot plots to draw conclusions, and we'll be looking at centers, shapes, and spread, just like from one, but we're comparing two different plots. Our lesson vocabulary is all of this is something you've done before, so let's just review it. First of all, we have median. And a median, and the median, is the center point in a distribution. So here we have an example of 9 numbers from 1 to 9, and they have different frequencies. So the median value, if you count which one is actually in the center, so the center number is 6. We have 4 numbers below it and 4 numbers above it. So the median is 6. And if there were if this is 10 numbers instead of 9 numbers and you had 2 medians, you would take the average of the middle 2 to get the median. The mean is another way to describe the middle of the distribution, and this is where you add all the values together and then divide by the number of values. So in the same 9 numbers, we add all of the numbers together. We get 47, I think, and we divide by 9, and we get 5.2. Let's see if that's right. Hang on. Let's try that one more time. Yeah, so 47, if we add all these together, we get 47, and then we divide that, because there are 9 different numbers, we divide that by 9, we get 5.2. So the median was 6, and the average was 5.2. The two numbers are not that different. The next term is range, the difference between the maximum value and the minimum value. I think this is something familiar. All you need to do is take the highest number and the lowest number. And the highest number in this case was 9. The lowest number was 1. The difference between those is 8. So the range, or the spread, is 8 in this particular example. And the last term we probably haven't used as much. It's called an outlier. And this is a value that's kind of far from the rest of the distribution, from the population. It just looks like it's different. So here's an example where we have most of the population between 10 and 20. We have one number at 0. So this 0 feels very different from the rest of them. So we call that an outlier, and having that in the population will change things like the average, maybe not as much on the median, but it will do some different things to range and to average, and so you need to know how to treat it. So in this case, the 0 was far from the rest of the values, and it's considered an outlier. So keep an eye out on those when you're drawing conclusions. All right, let's move on. Here we're going to compare two subjects. These are dot plots of scores of 25 science tests and 25 math tests. And we're going to look at them together and see what conclusions we can draw from them. So take a moment, look at the two charts. So let's see what we can see. Some of my observations would be that on the science, the most common score was 70, and for math, the most common score was 80, had the highest number. Also, the math scores had some hundreds and 130, and the science had 90s to 20. So the ranges, while they're about the same, it looks like the math scores in general were higher than the science scores. So let's give it a moment to refocus. And we'll move on and let's see some of the other things that we might have seen from this. Let's see if this helps. All right, so now I'm going to pull in some written observations to see how you would use mathematical terminology to describe them. All right, so as a group, the science test scores are lower than the math scores. So it does look like that. Just eyeballing it, it looks like this is a slightly lower population than this. This is a little bit more clustered at the higher end. Now, what we do notice also is the data is centered around 70. So in this case, in both cases, let's say in the first science case, 70 is the center population. So if you were to do the median, 7, 10, 12 below 70, and 7 above plus 1, 2, 3, 4, 5, 6, 7 plus 13. So the median value, if we were to lay them one lowest to highest, would be 70. Same thing is true of math. The center is around 80. So if you were to pick the median, it would be 80. So what we know is that the average, or the center, science is, yes, slightly lower in score than the math. And also we noticed, let's look at the spread. Science went from 20 to 90. Well, that's 70. And in math, the spread was 30 to 100. So the spread between the two was very similar to each other. So that also suggests that the math scores were better. The spreads were the same, then the centers would be the one area where we would conclude that the math scores were higher on average. So let's see, this is what we would do as a first step. We would look at the plots visually and see what our eyes are telling us in shape. Now we move on to a second example. All right, we're going to numerically compare the dot plots. Number of hours a class students spend on homework and the number they spend on television. So let's wait till it focuses a little bit. There we go. That's a little bit better. Okay, so eyeballing it again, what do you see? I'll give you a second to look at it. I see one thing. I see this outlier in television. We've got this student who doesn't watch any TV, but other than that, the range is from 10 to 20. For homework, the range, it looks almost more of a symmetrical, slightly more symmetrical shape to it, and it goes from 4 to 18 hours, with more of them above 10. So let's see what we can conclude. All right, let's look again at the shape. In the shapes, as we said, most of the data in the homework is 10 hours or greater. There's 3 data points in the low end, 4 and 6 hours. In television, most of the data is 16 hours or greater, but there are some at 10 and 12, and then the outlier. Now the centers, if you look at the homework, the median is going to be 12 hours. So that would mean that there is the exact same number of dots below 12 as there are above 12. On television, the median is 16. And even though there's one outlier, it doesn't change the median, because this outlier could be at 0, it could be at 10. Regardless, it would still put the median at 16. However, the spread is impacted by the outlier. So for the homework, we have a range from 4 to 18, or 14 hours. And for the television, if we include the 0, we have a spread of 20, which seems pretty wide. but logic tells us that's not realistic. So in fact, if we look at just 10 to 20, we have a spread of about 10 hours. So the outlier can really affect your range. It won't affect your median, but it will affect your range. So this is comparing and using more of the numerical data to make our conclusions. Moving on, let's talk about our turn here. Hang on, I'm going to cover some of this up for now. We're going to use this example for the next three classes, or three questions. So we've got Mr. Walker's class and Mr. White's class, and we're looking at the number of siblings in each. So let's use our observation powers again, and let's look at it. All right, so Mr. Walker's class has a higher number at 7 than Mr. White's. So the range looks higher. I'm not quite sure where this, and the spread is higher, so let's see what we see. So let's look. All of the siblings are 7 or less in Mr. Walker's class. That's one way to look at it. And all of the siblings are 5 and less in Mr. White's class. So one conclusion we could draw from this is that Mr. White's class has fewer siblings. And in fact, if you added them all up, you would find that adding up all the dots to Mr. White's class would be in fact less than the number of siblings in Mr. Walker's class. All right, what else? Interestingly enough, even though the spread is different, the centers both are 2. So the median with the most common number of siblings is 2 in both classes. And then the last one, let's look at the spread. The spread in Mr. Walker's class is 7, from 0 to 7, and the spread in Mr. White's class is 5. So Mr. White's class, there is a wider range or spread in Mr. Let me change that. Walker's class. So on your final paper it will be corrected, but in fact Mr. Walker's class has a wider spread. Now let's look at that numerically. So what do we say about the medians? So we talked about centers before. Let's talk more mathematically about medians. So the median number of siblings in Mr. Walker's class and in Mr. White's class is 2. And so using the median to compare the two classes is consistent with the visual observations we saw before, that both of them have a center at 2 siblings. And let's compare the spread. So now we're talking, instead of just the width of the spread, we're calling it the range. So the range is the technical term, and so the range is 7 for Mr. Walker's class, and there is 5 for Mr. White's class. So there is a wider range or spread in Mr. Walker's class. So summary of this, it's very straightforward today. How do you compare 2 sets of data displayed in dot plots? Well, we're going to get the practice of comparing first the shapes. That's where you first approach them and look at them visually and see what patterns you might see. Then you move on to the centers, and in dot plots, because of the frequency is a low number of points, most likely you'll be using medians. You could use means as well. And then the spread, and you can compare the median and the range of them now numerically. So with that, we're going to watch 2 videos from Dr. Berger, some more examples, and then the following day we will do our exercises in HRW for this particular lesson. So thank you very much. If there's any questions, again, reach out. And again, the lesson will be published on Monday afternoon for Tuesday. Thank you.